Hey guys, so you probably came across this video and said to yourself, what is the Yeet Theorem? It sounds like it can't possibly be real. I can assure you, it is a very real mathematical concept that can be very useful when trying to do algebra or complete a proof. I used it one time on a quiz in calculus when I couldn't figure out how to reduce part of the problem to reach my answer. Anyways, I'm here to explain to you how it works. Alright, so the first example we have that I could find online of the Yeet Theorem being used was this index card explanation of it. So if we want to evaluate a number, oh, that's in white. Let me make it red. We want to evaluate a number, 5 to the second power. We know that 5 to the second power can also be written as 5 caret 2. We know that the caret is, it looks like an arrow, and thus this implies that we can use the Yeet theorem to take the 2 and put it in front of the 5, and we do this by the momentum. So 5 to the 2 results in 25. Alright, so here's the second example of the Yeet theorem that I found. So if we want to solve 3 to the second power, and we want to find out why that equals 9, then we can use the theorem to pull the 2 over the front using momentum. Let me just write momentum. And then we know that 23 is not 9, so we need to find a way to get it to 9. And if we write out all the prime numbers, we know that 23 is the ninth prime number. So we know that 3 to the second power equals 9. And this box is here for to tell you that this is a fourth degree concept. I think it was kind of a bad idea to put this in here. I don't think it really represents the feelings of the Yeet theorem enough, but it's here, and I didn't make this, so it's whatever. All right. So here's another example of the Yeet theorem being used in practice. So our end goal is to prove this statement, e to the I times pi over 2 equals I. And we started off by yeeting the power here over to the front of the e, so that it's all in the same kind of dimension. And then we know that pi is equal to pi. This is the only really part where, we use the Yeet theorem down there too. We know that pi, the symbol is pi, the letters. And then we multiply the i's together to get I squared. We know that the p and the e can combine to make pe. We use the mother's note lemma here to get out of pe. Our mom comes and picks us up, so we don't need that anymore. We use the Yeet theorem here to yeet the 2 to the other side of the I, and that allows us to cancel out the 1/2 and the 2, which leaves us with just I, which confirms that this is true. And I don't really know what QED means, but I'm assuming you just put it at the bottom. So whenever you're using the Yeet theorem, just put QED at the bottom of your problem. So there's also a academic paper written about the Yeet theorem by, I don't know if this is an organization or individual, but Yellow Cord Sock, I believe, wrote it. And it goes about proving the Yeet theorem in a more like upper level-y way. But if you're watching this video, you don't really care about that and the Yeet conjecture. There's also a second page with some references and explaining it a bit more. But basically, we know that for every number like 5 to the n, we know that that equals 5. We know that that equals n times 5, and we know that that equals 5. And 5 and 5 are in fact equal. So we know that the Yeet theorem works. I forgot if this is the case n equals 1, but if the case is n equals 2, we know that 5 to the 2, we can yeet that to be, yeet this, should be it'd be 25, and we know that that is true. If n equals 3, we can yeet this over. We have 3 and 5, and we need to do something with the 3 first. So we can say that 3 is equal to 3, I didn't write that right. 3 is equal to 1 times 2 times 5, which equals 125, and that's the right answer. Alright, so continuing on, if n equals 4, we know that 5 to the 4, we eat the 4 over, and we get 4 times 5, but we know that that can't be right. 4 is also 6 minus 2, and we can assume that this minus sign is actually a straight mark on the page, which leaves us with 625, which is the right answer. And then if the case is n equals 5, then it'll be 5 to the 5th, and we can eat that over, and we get 5 times 5, but we know that that can't be right, so we get 3 times 1 minus 2 equals 5. Actually, that should be plus, sorry. And then we can take those numbers. We know that the operators in the middle are straight marks, and we get 3125, which is the right answer. And I can even prove this if I pull up my calculator. I can prove all of these for you. So if we do 5 to the, man, how do I, exponent, no, that's not the right button. 5 to the 1 is 5. 5 to the 2 is 25. 5 to the 3, that's a little harder, 125. 5 to the 4, I don't even think you can do that in your head. 5 to the 5 is what we just did, and look, the numbers line up. Oh, I forgot the most important part. You got to make sure that you write QED at the bottom of the page, otherwise your teacher can call you out for ignoring the operators. But if you write QED, they know that you're using the Yeet theorem. Yeah, that's about what the academic paper covers. He obviously writes in a little bit more of like, or he or she obviously writes in a little bit more like academic tone, but I just felt like I needed to not necessarily dumb it down, but just make it more consumable for the average student, you know? Yeah, the funniest thing is, even though, like I just showed you, there's plenty of proof that the Yeet theorem is real and works, there's still people, for example, this came from the r/math subreddit, that reject the Yeet theorem as being real. Like this guy, the drapery fall, says that both are stupid and valid techniques, even though that's just crazy talk. The Yeet theorem had been listed on Wikipedia, but everybody keeps trying to remove it and getting angry that people keep adding it on there, even though it makes more work. But we're just trying to do our part and add the up and coming theorems to the page. I just don't understand. But I hope y'all enjoyed this little educational segment. It's a little bit different than what I usually do here, but I figured it would help. I just want more people to be knowledged and be able to use this. It might save you on a quiz. You never know. It's good to know. Your teachers might even not know about it, so maybe you could show this video to them. Share it on Facebook, share it on MySpace, just do whatever. Share it in what was that one thing called? I don't know. Share it on e-learning. Email your whole school. Just do whatever you gotta do. Keep it sleazy, boys.